Nice.
of July. I'll be there the 10th to the 3rd.
Oh, wow. A couple weeks.
Yeah.
Nice.
Yeah. So that'll be good. But yeah, so I'll be there the full week before Tim's wedding, and then through Krista's wedding. Didn't make a lot of sense to leave and come back.
Yeah, definitely.
Cool.
Yeah, I look forward to it.
So I believe we are now recording. As soon as my screen confirms that.
It says live on YouTube on my screen.
Good. It always gets you guys before it gets me. I just got to make sure that I click off the sound. I do that every time. It's telling me my internet connection is unstable, which is not a good sign. Shouldn't be. Let me shift. So I'm moving. Internet. You may lose me for a minute.
All right. John, I went to this insane mountain biking place yesterday.
Oh, yeah, nice.
So epic, dude. It was unreal. Like,
That's super fun.
huge jumps, massive hill, like these crazy boardwalk things through the trees.
Oh, yeah, I've seen those before.
Dude, it's nuts, man. I came so close to hurting myself. Oh my God. I wiped out so bad twice. Damn. Holy crap. And
you're talking Mount Hood skiing or what?
No, mountain biking.
Oh, mountain biking. Okay.
Mountain biking. It's at this place called Black Rock Mountain Biking.
Make sure that
near Fall City.
Click off the sound. They do that every time.
But it's a crazy place. It's this huge hill, and you're biking through this super big stand of trees. So they're like 100-year-old trees, and then you're just riding these crazy awesome trails with like big banks and ramps and jumps. Wow. I was so out of my league, man. I'm so lucky I didn't die. Yeah. I went off this jump and slid forward and landed on the frame of my bike, and then slammed into a tree, and it flipped me up around. I barely missed the tree to the left of the tree, and like flipped up and then landed on my back and just slid down the hill for a bit.
Jesus.
And then I got stung by a bee right as I got done. Like bang, right up the arm.
Tiny little insult to injury.
I know. But my legs are a wreck. I got these big bruises everywhere.
Jeez.
But just gotta get better at it, you know.
Yeah.
And I have health insurance, so I'm good to go.
Outstanding.
How are we doing over there, Uncle Tom? Are we ready to do this thing for real?
You'd have thought so. I got to get to PowerPoint, and unfortunately, I got a couple copies open. But I think I got it now. Let's see.
There we go. I'm seeing your screen.
You are, but unfortunately, you're seeing the wrong stuff. It's as if I've minimized the file or it's closed on me. So you're seeing through to my browser when you're supposed to see my PowerPoint slides. Hey, by the way, this is the Resurrecting Civility podcast. Welcome, everybody. This is John Loughran, John Rose, and me. I'm Tom Loughran. And in case you ever join us, we're talking about a big project, which we're calling Resurrecting Civility. We talk about a lot of things. We're trying to rethink how we interact with one another by weaving together a different picture of who we are and how it makes sense for us to interact and understand ourselves and one another. And that big picture we push forward a couple times a week, and then we sort of I think it's fair to say we sort of live out of the civility we're trying to resurrect yet another day of the week, somewhere in the middle where we talk about all kinds of different things. So, so thanks everybody for joining us. So now I'm hoping you guys can see a bona fide PowerPoint slide that says Resurrecting Civility on it. Is that true?
That's what I can see.
Super.
Yeah.
Okay. I'm going to take us back a little bit because it's a while since we did this. We put four episodes actually into talking about truth and goodness on a certain model of dialectical reasoning. And we talked about conscious realism and how conscious realism seems to, in some ways, fall out of that. We did that for a while. The very last time we met, we had one of our open topics. And here we are talking today about not conscious realism from philosophical concerns, but conscious realism from physics. And this will be the first of a couple of different ways of getting at that. And I'm introducing a phrase here, I've snuck it in. I'm calling it an alt realism pathway. And what I mean by alt realism, I'm just using alt instead of other, because that's the cool thing to do these days. And what I really mean by it is clear on the next slide, pathways to alt realism. And I mean, starting with something besides physicalism, starting it was something besides the space-time universe is what is real. So in that regard, since physicalism is often understood as that claim that space and time is real, is fundamental, they're fundamental particles, et cetera, that's the reality we have. It's physical reality. And everything else that comes, that we know of is somehow built up out of more fundamental pieces that are part of that space-time fabric. That's physicalism. And we're starting instead with something else and deriving space-time. That's the alt realism handle that I'm sticking out here. And again, looking back, we've looked at some ways, we've hinted at a few ways from a philosophical approach that takes us here. One is even just the way we started. If you think of what you're aware of as information, you're informed all the time in decisions you make by things that you are aware of, at least so it seems to you. And if that is information, without saying that everything that's information is that, if that, what it is you're aware of is information, if that's the case, then you might wonder how you ever get out of that in the first place. How do you go from what you're aware of to anything else that's real? It seems like you start with the fact that you're aware of things, and that seems real. And then what else comes from it? Well, you might imagine nothing does, that you're trapped in there, and that's sort of one route to conscious realism. Maybe it's sort of to give up on the possibility that there's more than that. But we also built inside that framework, we built a conception of truth as a stable outcome of holistic, theoretical, and practical inquiry in what we're calling a high information flow network of rich communities. And you guys have seen the cool picture. And if you're interested in this line and you haven't seen that cool picture, you'll see it again. It's not that cool actually, but it works for us. So from that conception of truth, without going through this again, that's what we hit in episode 10 and previous ones. There's a couple others that I want to throw in here, and we've alluded to them, but now's the time to categorize them. And that is, first, the hard problem of consciousness, which people know. I mean, imagine you start with physicalism, then you got to say something about how you get to consciousness. If you don't go the alt realist route, you got to go the physicalist route, right? And that has really got some challenges. And you might wonder, and I think you've seen David Hoffman throw this into the mix. In fact, it seemed to have motivated him to probe the evolutionary pathway that he eventually does probe, is just the dead end that he and so many others have hit, thinking about what consciousness is and how it could possibly arise from the brain. There are, of course, many theories, but those theories are not yet functioning in ways that people are very happy about. They do seem to promise potentially falsifiable trajectories, ways of experimenting, and we'll see how all that goes. And what you might say, though, is that we've been thinking about this for thousands of years, or hundreds of years, or decades, depending on what you think is necessary for solving the problem. And we have not seemed to have solved it yet. Maybe it's time to try something else. That's one way of thinking about this. It's a sort of a philosophical route to a motivation to peek at an alternative way of looking at reality. And then finally, I heard yet another of Donald Hoffman's many discussions recently, in which he says, look, we have no idea. I don't, and neither does anybody else, what morality is. We have no scientific account of morality. To embellish what he said in that, and I'll share that link with you eventually, to that interaction. It came post Sam Harris. It's more recent than his interaction with Sam Harris at the turn of the new year. Yeah, he says that that's true, and I think it is broadly recognized that there's a difference between people who are wise and people who are foolish, and all kinds of societies recognize that distinction, and yet we don't seem to have an agreement about what it is that the wise people know and the foolish people don't about how we ought to live our lives, about prescriptions for living well. We tend to think that there's moral wisdom, and yet we can't, even in our best. There are, of course, some people who think they know what it is, or who deny that such a thing exists, or they know what to say about it, but they just can't convince any of their colleagues. And that's what I mean by intractability. It's a big problem. And I shouldn't say that they can't convince any of their colleagues. They can't convince the majority of their colleagues. There's no paradigm that we've sort of grouped around. And you might wonder whether there may be something missing there. And that, of course, is Alistair McIntyre's work. You bet there's something missing, right? And not just McIntyre, but G.E.M. Anscombe in 1958, which happened to be the year I was born, a British philosopher who's argued in a paper called Modern Moral Philosophy that we ought to get rid of the language of morality if we can possibly can, because we don't know what it is. It's referring to something that's now gone. So what is it that's gone? In a certain sense, if we knew what it was, maybe we could recover it. That's sort of the resurrecting civility project. But we'll leave all that for now. Finishing here now, this is sort of different pathways from a philosophical perspective that might drive us to explore at least an alternative realism, or maybe even to generate an argument for it, which is a little bit different than, boy, it's a good idea. It sure would be nice if we had this, and maybe it's more fruitful if we look over there. There's a different kind of argument than I have a deductive argument where I think all the premises are true, right? And it leads to the conclusion. But there's both of those, and maybe other kinds of arguments as well, mixed in this philosophical pile. So that's one set. And then, of course, Donald Hoffman, who we've been listening to and has written this case against reality. He doesn't really mean against reality. He means against what we all take to be reality, which is physicalism. He thinks that's not so. He knows that the hard problem is intractable, which is part of his motivation. But as a scientist, he is an evolutionary theorist, like everybody else is in the field, and he thinks that he has experimental results that imply, as he puts it, I think there's zero chance, right? That what that we have evolved to see what is actually there. There's zero chance of that. And that there's a divergence between fitness payoffs and homomorphic, non-fitness payoff homomorphic alignment or something like that with reality. So that's a pathway from evolutionary theory. Today we're going to focus on a third area. Not that we won't come back to any of these others, but I want to look at a third area for a little bit, in part because there's a little bit more going on here than I knew about. And I want to drag a couple of other projects in here just to point to them. Over time, we may go there and learn. One is Brian Whitworth's, and the other one is Tom Campbell's. But I've looped Tom Campbell a little bit lower, and we'll talk about why that is in a minute. But I want to start after this physics route. Of course, Donald Hoffman points out that there's a physics route. So if we've done Hoffman, we've seen that, and you go to his, I think it's consciousrealism.org. You go to that site. It might not be that site. Don't quote me here. Just because we're live on YouTube doesn't mean I should have it right. But anyway, he's got Nima or Kenny Harai's pronounces his last name wrong all the time. In any case, Nima's stuff, and there too, from a variety, he knows way too much physics for us to try to be able to catch him. But surely, from among the things he's grappling with are the difficulties in coming up with a quantum account of relativity, or a relativistic account of quantum mechanics. Neither of those seem to work, and in fact, something else wonderful seems to work, and it seems to imply that what we know as space-time somehow emerges from some other mathematical reality, and he's chewing on that. So that is one attempt that you could say that it's a kind of alt realism, but I want to be careful how far I separate it from physicalism here. He's not separated it from physicalism, but he has separated it, or maybe is committed to separating it from space-time is fundamental version of physicalism. Maybe there's some other version of physicalism. A mathematical physicalism? I don't know. In any case, he's pushing us in a different direction, and it's a direction that Hoffman and others align themselves with, and think that evolutionary theory pushes them in that direction too. Jumping back for 1 minute to our dialectical reasoning within this high information flow network of rich communities, and this stable account of truth, in which all of inquiry is on the table, is bundled together. Every area of inquiry gets connected with every other area of inquiry in some ideal, right, and gets knit together into some kind of a whole. On that model, all roads ought to lead to whatever the picture is, right? If whatever is real, somehow all roads ought to at least be compatible with it, right? And perhaps lead to it in some way. I'm getting ahead of ourselves, but I just want to hint backwards and suggest that maybe it's not a huge surprise that there's these multiple roads. There ought to be multiple roads. If there weren't, maybe we shouldn't believe it. That's sort of an epistemic issue. But maybe there's something else that ought to be the case. Whether we should believe it or not, maybe if it were real, it ought to sort of show itself all over the place in lots of different areas. Okay, so what I want to focus on today is just this piece here. A view that there's something about quantum theory which points to what Brian Whitworth calls a quantum realism. And we'll take a look at that shortly. We'll spend almost all our time on it. But before we do that, I just want to lay out one other piece. Here I want to introduce Tom Campbell Tom Campbell has an account he wrote in, gosh, what years were these? It's been a number of years now, and I think it was in the 2000 aughts, the 03, 04, 05, 06, somewhere in that range, wrote a theory of everything, a TOE, as it's sometimes called, and he put it out as my big theory of everything, or my big toe, and sometimes it's now referred to as MBT for that reason by people who are fans. Tom Campbell is let me say he's physics educated, and he's lived a life as a professional physicist. He didn't actually finish his PhD. He was sort of ABD, as they say, according to his bio. But he got out and went to work for NASA for a lot of years, and is basically a missile guy and a quality control guy for NASA. So that's the life that he lived. But at the same time, he ran into, you could say, people who spent a lot of time meditating and thought you could learn a lot through it. And those folks, Tom Campbell, I haven't heard him call himself this, but sometimes people use the phrase psychonaut. And I think they allude, right, to that practice, right, of exploring the world through meditation, entering into the world of consciousness. After all, if we are conscious, maybe we ought to be able to look around, right, and see what's there. And it isn't only, the things that are there are not only the things that our senses give us, but sometimes we can quiet those, the hope is, and grasp at other dimensions. And that's what I mean by psychonauts, right, as if they're traveling through psychology. And Campbell doesn't mean, I think Campbell means to be a scientist, and he means to be a physicist. And as you will see when we run into Tom Campbell, he spends an enormous amount of time in quantum theory. And in fact, he's paying for a new version of the double slit experiment to be performed at a university out on the West Coast somewhere. So he thinks that he has a testable theory, which is, he doesn't precisely use the phrase conscious realism, but he does think that what we see now is something like a virtual reality, and it's generated by conscious beings, a network of them. And here he sounds an awful lot like Donald Hoffman. He thinks that what Donald Hoffman's doing is right up the same, barking up the same tree that he's pursuing. So he says. And the same thing I think is true with Brian Whitworth's work. He also thinks highly of Brian Whitworth's work. Brian Whitworth is, as we'll say in a moment, is a computer scientist from New Zealand. Okay, so those are some of the various folks that are out there. And eventually, if we go very far down this road and start to articulate an account that looks like these other accounts in some ways, we're going to have to say whether it is such an account, whether it's the same as these other accounts or different, and how. Just because they've, and frankly, we can learn a great deal from them. Whether they're right or whether they're wrong, they're certainly thinking hard about where they think these roads lead. Okay, so if I may, let's shift gears and sort of get some work done. This will be a 2-minute introduction of Brian Whitworth, and then we're going to dive into some quantum mechanics, which is kind of ridiculous, but that's what we're going to do. Because we got to get some feel for what it is that's scaring these people out of the corner, right, and into the bright, out of the physicalist corners and right out into the bright light of conscious realism, if that's what it is, or whatever it is that's happening. They certainly are changing their view. So here's, and this is simply an old slide. That's the idea. So you can, if you want to sing along here, you can go to brianwhitworth.com, just there, or you could grab this very slide from his quantum realism page. Now, Whitworth is a pretty serious computer scientist, and I'm going to sell him short, but he's got 75 plus publications and cited many hundreds of times, and has taught an awful lot of in computer science, and especially in the relationship between the human brain and computer science and the mind, what do they call that, the machine brain interface. He spent a lot of time in that space. Here's a little account of what he thinks is going on in the world, according to him. This is his account, and I just sort of stole it. And you can see that he seems to be about quantum. At the bottom of this pyramid, he says there's a quantum reality, and he calls this the observer reality. And at least for that reason, you might ask the question, what does he think, who's observing, right? Are these conscious entities that are observing, or is there something else that's not conscious that's observing? But in any case, there's an observer reality at the quantum level, and he thinks that that is underneath physical reality, and that the right way to think of all the things you see and you hear is as a virtual reality that's being simulated. So does Tom Campbell, as far as I can tell, literally as if there's computers running somewhere. And running somewhere where will be the question, right? So they really think that this is a virtual or a computational reality. And I just don't mean that you can do computation in it. I mean that there is computation underlying it and producing it in the way that in the way that happens, say, if you're in a virtual world, you know, with a VR headset on, right? And there's code underneath all that. And it looks like, and here you've heard Donald Hoffman, so I'll use his language. You know, it looks like there's a red Ferrari and a green Mustang or whatever the colors are in Grand Theft Auto, but there actually aren't cars there, and they're not there when you look away, right? When you stop looking at them, they are no longer rendered. Campbell thinks of it that way, and I think I think that Whitworth does too, but I'm just learning these, I'm just getting to know these guys and working through their stuff, so I could be wrong. So we'll give them the benefit of the doubt if that seems crazy to you, or if it seems plausible to you, then maybe they think so too. Okay, so that's all I wanted to do is lay out the slide, mostly just to say that it's, there are folks who are looking at the quantum world and thinking that somehow there's an observer reality that's underlying the observed reality, which they equate with physical reality. And this sounds a little bit like alt realism. All right, this is the last slide we'll do today, but it will take us a while. All right, so let's see. You guys have seen the double slit experiment. And if we looked at that in all its glory, which is really worth doing, actually, it's a marvel of, it's really a marvel of technology to see these. And the next time we meet, I'll drop in another link that I found, which actually shows you a benchtop setup of what this actually looks like. And it's pretty complex optics environment. But here's this guy. Have you guys ever run across Joe Scott? He makes science make a lot of sense. He's a very good science communicator online. And I've sort of shamelessly stolen his explanation. And I recommend that you guys click on it sometime and go through it and watch it. Because this one is about 16 minutes long, and it's full of him slowing down and letting you digest in his own way and having a little fun. We're not going to quite
Do you lose him, John? I can't hear Uncle Tom.
do that. I don't even know, frankly, if it's legal. There certainly is in terms of, and I just don't know what you can, you know, can you play a video, a YouTube video inside a YouTube broadcast? Physically, you can do it, but I don't know what you're allowed to do. In any case, if I've gone too far here and this level of attribution isn't enough, then I'll apologize and retract. But he's done a great job, so let's follow along. Here is this is a little instrument that emanates that spits out all kinds of different things. It could be photons, and let's imagine it's photons from here on out. But I have to tell you that this works with anything. It works with electrons too. And in fact, it works with hydrogen atoms too. And it even works with buckyballs, C60. I don't know if you've ever seen buckyball form of carbon. It's basically a soccer ball with all of the carbon atoms bound to one another in a remarkable it's sort of along the graphene lines and carbon nanotubes, et cetera, but it's round. Those other pieces are important in a lot of molecular nanoelectronics that are coming out. Buckyballs might be too. The full name of that is Buckminster fullerene. They actually can spit those things out. And everything we're about to say of light, I think, I don't know how much of this has been done with buckyballs all the way down, but the fundamental pieces of this cool mystery have been done with buckyballs. Moreover, I'm recalling, this is something I've only read once, but I think it's true. They've done it with proteins, which are relatively big molecules, bigger than even C60. So you can throw chunks of matter, apparently at what? Well, let's imagine that say that little yellow ball, you can barely see it. I can fix that actually. Is this a little bit more helpful?
Yeah.
Okay. So you're throwing, imagine throwing, say, water waves, a whole pile of water waves, and you got a couple of slits. Then what will happen is each of those slits will function, if they're small enough, like another source. And just as the waves will sort of move out from your hand, if you push in water with your hand, you'll get this large concentric set of ripples around the direction that you're pushing. The same thing will happen when you pass it through, and you'll get two other sets, and those sets will interact with one another and reinforce one another sometimes and cancel one another other times, and you'll get an interference pattern, and it looks something like this. Again, all this courtesy of Joe Scott, of Joe Scott, but we could have grabbed it from a lot of places. This is just a real simple bare bones illustration, okay? So imagine now, I grab this picture of an interference pattern and I drop it up on here on what's meant to be a screen. So if you throw water through, you get that. If you throw a whole pile of photons, if you shine a flashlight on a couple of double slits like this, these are long slits. You have to imagine these sort of are walls coming up at you and you're looking from the top down, okay, down the z-axis onto this x and y axis down here on the floor. And if you shine light through those, the light will do the same thing. And you might say, well, that's because some of the light goes this way and some of the light goes that way, because you got all kinds of different photons. We know about photons, right? And so these clever guys can tune down, squeeze down the flow rate to one photon at a time, as slow as you like. And they can fire a single photon in this general direction. And what will happen is you get an interference pattern over here, as if it went through both of these slits and formed and they functioned as if they were individual sources. And you get this interference pattern of reinforcement and cancellation, just like this. Even one photon at a time, even one electron at a time, even one buckyball at a time. Go figure. Okay, so that's pretty strange. You might think, well, maybe that's something strange about light. It's strange about things that have wave-like properties, which according to the de Broglie hypothesis is everything, including us, right? In inverse proportion somehow to the amount of mass that it has, but nonetheless, very, very high frequency waves associated with us relatively heavy entities. I say that about debroiling without having looked at it in about a bazillion years, but we'll check on it. I think that's correct. Okay. Well, we want to know what's going on, so why don't we just look? Why don't we put a camera here and watch one of the slits really carefully? And we'll see if anything goes through this slit. You might wonder how you can see a photon going through a slit. Good question. There might be little bits of reflection. After all, when this thing goes through, it looks something like this, right? And so some of this wave ought to be picked up over here as well as over here. So maybe you can put this little guy off on the side and pick up a photon when it runs through. And then we'll know whether it went this way or that way, or maybe at least we'll know if it went this way. And if you want to know at the same time whether it went both ways, just stick another one, call this A, slit A, camera A, detector A, slit B, detector B. Okay? Well, what happens when you look is you don't get this interference pattern anymore. What happens when you look is they just pile up in straight lines and just piles, exactly like you would expect. If you were shooting BBs through here, BBs do not give you an interference pattern. If you randomly, or if you blew a shotgun spray right across this whole thing, you'd have a couple of lines of buckshot. I think you can all sort of see what I mean, right? That would have made it through these vertical slits, and or the same is true with a spray painter. Maybe a better analogy. Literally, you'd paint the wall and there'd be two slits back there. You wouldn't have all these interference patterns if you just threw spray paint there with a double slitted mask. You would get two lines, right? But when you look at these, number one is that's not what you get when you throw buckyballs through there or anything really small, or when you throw photons through there. You just get this reinforcement pattern, which already ought to mystify us a little bit. But now it turns out that when you look, you don't get that pattern anymore. Why would it care? If you were looking at paint and paint were flying all over the place, would the paint care that you looked at this paint and got it dirty over here with that alter, the paint that was flying in this direction? Not obviously, right? I mean, you would think obviously not, actually. So this is the double slit experiment, and this is a phenomenon that people have known about for about 100 years or so, and they've been thinking, gosh, what's up with that? I wonder if we could do this more carefully. So we got this really clever little device here. It's some kind of a crystal, and what it does is it converts this, it splits it into two lower energy photons. And so we'll send this photon this way through this crystal, still through the double slit. But what we want to know is what's going on the other side of the double slit. That's why we put the camera in the first place. And it changed the stinking behavior we were just looking to peek at, right? So let's try peeking at it a different way. Let's instead don't peek at this photon and don't peek at this other photon that go toward our plate, our detector plate, this plate. Let's not mess with those guys, but let's peel off some of that energy as another photon. And when we peel these things off, we get what's called entanglement, because there are conservation laws that have to be obeyed in this interaction. And conservation of whatever this spin was, there has to be a net result here, and whatever, there are all kinds of conservation laws. Let's not mess with them at the moment. The point is, because of conservation laws, you get entanglement. So it turns out that if you read one of these electrons, you know it's true of the other one. Or if you looked at one of these photons and it was polarized in one direction, you know what's happening with the other photon, which has to be polarized in a different direction. Okay, so we ought to be able to deduce what happens over here without directly looking at it, by directly looking at its evil twin, so to speak, right? It's complementary entangled particle. And when we do that, we get no reinforcement pattern here. When we try looking sneakily through the entangled friend of the particles that are interacting, or we were hoping would interact, we thought would interact if we left them alone, like they seem to interact when we leave them alone over here in our first case, right? But maybe we're messing with it over here somehow. We thought we were leaving it alone too, and just peeking didn't work for us. Let's try to peek this different way. And it turns out we still don't get our phenomena. We don't get our reinforcement. It's as if we're looking and we're not allowed, when we look, we don't get that. When we look at which way these things traveled. And if we detected something here, we would know of a single photon which way it traveled, right? Because if it traveled through this slit, it might show up over here and it might show up over here, but it wouldn't have shown up over here if it went through the slit, right? The optics are wrong for that. Does that make sense? You guys see this well enough? John, JP, sorry, you've seen this stuff before, but hard to pick it up.
Yeah, no, it
Okay.
makes sense to me and looks familiar.
Okay. All right, so that's a result of that experiment. Okay, well, maybe the problem is these guys somehow know that we're looking. So let's see if we can remove that from the equation. Let's back these cameras up as far away as you like. If you need more time, take more distance. Speed of light is constant, right? And just drag these guys, these A and B, way, way off into the distance. And run it again. And what do we get? No interference pattern. Well, wait a minute. How does it know that we're looking way down here? The photons from their evil twins didn't get there yet. And yet there's no interference pattern. Why is that? Shoot. Because we looked in the future, so to speak, right? I mean, that's what you want to wonder. Is it because we looked in the future? Are we not somehow not allowed to know? Well, let's imagine maybe that's the case, that we're not allowed to know if we're going to get that interference pattern, if we're going to have the two of them move somehow in that way that acts as if it went through both slits, the way waves act when they do go through both slits, the way a single photon does act when there are two slits and it shows up on the other side. There's the neutral way to put it. When there are two slits and we detect it on the other side, that's what we know. We get an interference pattern from a single electron, and we're dying to find out which way did it go. So these are sometimes known as which way experiments for that reason. We're trying to cleverly figure out which way it went with these cool detectors. So we look way, way, way down the line, in effect, in the future, from the point of view of this collision. Well, what happens if we unplug these guys? What happens if we move these way down, but we pull them out of the wall, the electricity out of the wall, and we don't look? That couldn't possibly make a difference, does it? I don't have a drawing for this. Actually, it does make a difference. If you unplug them, you get the reinforcement pattern. Now, I haven't done this experiment myself. This is what people say. The same is true over here, by the way. If you and this was a place I could have made that point. If you unplug it, literally leave it there and take the plug out of the wall, you get reinforcement patterns. Put it this way, if that's true, you can understand why people would say this is strange. Okay? So we'll put a little reality check, physics reality check on the things that we're about to say, if it's true. I understand that it is. So then you can move these all the way down. You can move them so far down and then make a decision after the light has had to have traveled, say, half the distance down to detector A and B, which is, say, twice the distance it takes to get here, right? And make a decision halfway down, twice the distance after it had already arrived there. Make a decision about whether you want to pull the plugs out of the wall or not, so to speak. Probably there's some kind of cleverer switch than that. Okay. But that's a common sense switch. And it turns out that our pulling the plugs out of the wall after the light had made it halfway down and twice as long as it took the light to make it just to this detector, our pulling the plugs out of the wall makes it be that that interference pattern is visible. Now, already you can run into questions like, wait a minute. I mean, wait, could you take a picture of it? Right? There's all kinds of questions, and I don't know the answer to all those questions. I do believe that those are the right questions to ask, and the answers are as mysterious as you might imagine. I think that's the case. All right. One more step. This is as weird as taking the plugs out of the wall, and this one isn't. This one isn't being made up by me out of my memory of what's possible in these experiments. This particular experiment is what Joe Scott, once again, what Joe Scott was setting us up for. This experiment is sometimes known as the delayed choice experiment. Actually, this already was a delayed choice experiment, right? I was delaying the choice as to whether turn these detectors are on or not. And you already seem to get the conclusion here that something in the future, a choice in the future, if I delay it so that it happens later in the future relative to the original, what should have been that original detection, delaying that choice seems to change the past. Seems to have a causal effect, or at least a one-to-one correspondence effect on the past. It's correlated with the past, whether it's causing, who knows what that is in quantum physics. Okay. But this particular one is way cool. And it's a delayed choice experiment too, but I think this one's called the quantum eraser. So not only can you change the past by an action in the future, but you can erase the past by an action in the future, and this will erase it for you. Imagine you said to yourself at this phase, damn, we're getting weird. This is just weird. Does it really care if we're plugged in or not? I mean, is there some physical connection? Does it somehow, are we doing something physical that is interacting with with matter back here, right? Or over here, or who knows how that change gets made? Is it about the electricity, or is it about what the electricity is telling us? By the electricity, I mean the electricity to power A and B. Is it about the electricity, or is it about what the electricity is telling us? Is it about our knowledge? It couldn't be about our knowledge, could it? Well, let's see if it is. Let's leave the electricity on for these detectors, but erase only our knowledge. Now, how can you do that? Believe it or not, somebody came up with a clever logic for that, like this. Now, if you want to get to the bottom of this, you watch Joe Scott's video about 10 times and then watch another version of it. and eventually you can follow it, okay? But the basic idea, after my trying to do that a number of times, the basic idea that I'd say will make a believer out of you without necessarily making you an optics expert, fully on top of exactly how the light is flowing and why and et cetera. Notice that there are two detectors here which see only light from one of these streams. They either see the blue light that came from slit B, or they see the yellow light. And I don't mean these are actually different wavelengths. Different colors are different energies, different wavelengths, as you perhaps know. Both of you guys know that. And that's not what I mean. This just happened to be drawn in a color so we can follow the logic, right? So blue is slit 2, and yellow, it came through slit 1. Detectors A and B, you can see, only get light from one detector. Detectors C and D can get light from either detector or both detectors. So what's happening here? A photon, this is still a photon at a time, somehow makes its way through to the other side of these slits. We have reason to think so because we get detections at various sorts over here. And we put a beam slitter in front of either of these ways, and we create entangled sets. If no matter which way it goes, we get an entangled set. And then down the road, we get 2 detectors that will tell us. One of them will tell us only if it went that way. And the other one, where's the other guy who gets a yellow, is detector D. But detector D will also light up if the light happened to pass through slit number 2. In other words, if it becomes this blue light, right? And if it survives this, these are all half silvered mirrors that let some light go through and some light not. Okay. So let me just say that the optics, the logic, which is written in the optics table here, there's a logic that's written in the optics table which does not allow you to know which way the light went, though it went as it went. These detectors are still plugged in, and the light still did all this, and it still did all this, but it did something else down here in the detectors. And what's the difference? As far as we know, the difference is now we don't know where the light went. And when that happens, we get the freaking interference pattern back. As if what really matters, so people, this is us, I've set it up, not disingenuously, I think I'm following the physics. I've set it up in such a way that is the way other people set it up, and it's definitely the way, I think it's definitely the way. You can correct me if I'm wrong, or somebody else can who watches and sees better, right? It's the way that Joe Scott and other people describe it. He does a good job explaining these things. And it seems like what's going on, and it was meant to test whether what's going on is whether it's our knowledge that makes a difference. And it somehow it says, sorry, you don't get to know that. You don't get to know which way it went or whether it went both ways. You don't get to know how it created this interference pattern. If you set it up in such a way that you can know it, it won't create it. If you set it up in such a way that you can no longer know it, though there's all kinds of detection going on here. But if you set it up so that the logic does not allow you to know it from the detection that you're actually doing, which is just as much or more detection as you were doing up here, as long as you don't know, this is what you get. And that's freaking weird. And it makes it look even up here, because I say up here, we can move this too. these two path lengths right here between this crystal beam splitter and these first two detectors, A and B, make them arbitrarily as long as you like, right? I mean, make them, for example, 4 kilometers long. I happen to make that one in mind because that's what LIGO does with its lasers, with its light. It runs it for 4 kilometers down each of its to tiny little interferometers, and is trying to detect wiggles in that light, or rather wiggles in the space from gravitational waves, by looking at all the other sorts of things that wiggle the detector within the diameter of a proton. I mean, unbelievable precision, okay? So apply that unbelievable precision here and draw this way the heck down and decide whether you're going to turn these on or not turn them on, or change the logic in this thing so you can know rather than that you don't know, right? You could do all that with on-off switches. And it seems like when you make those choices, you're changing the past. It seems like somehow your knowledge, your participation as an observer, which I take it is as a conscious agent, surely in this case it is, unless there's observers that are not conscious. And surely, I mean, can you choose without being conscious? I suppose maybe you could. But the choices that are being made here are choices by conscious agents. And it seems like you can choose. If we have free choice, it seems like you can choose freely, and our free choices determine the past. Those are questions that are set up. And because they're set up, and because people have been chewing on not all these results are decadal results, but there's century results that are being worked here. That light, that electrons, that all kinds of things behave this way at the quantum level, right? That when you look, when you try to get which way information, sorry, you can't have it. Sorry, guys, give me just a second.
No problem.
Anyway, this behavior is weird, and we don't seem to be able to explain it. And so, boom, guys like this come along and say, wait a minute, there's another way to look at this. And they come up with very clever software. And the guy who's made this clearest to me actually is the other fellow, Campbell, Tom Campbell. Whether you like his whole project or whether you don't, he knows what an algorithm is, and he lays out an algorithm that will produce for you results under these circumstances. In other words, if you want to simulate these results, here's the algorithm that will simulate these quantum effects. Does that make sense? And he breaks it down into 5 steps. And if we want to, we could look at it. And frankly, it's at some point you get bored because you say, of course, that's the algorithm for it. I mean, it's utterly clear, but he breaks it down. So if it wasn't utterly clear to you that it could be simulated, he shows you exactly how you simulate it in painstaking detail, right? Like if somebody, like a physicist would. So I think I've now motivated. I think I'm going to stop and let you guys in. I've sort of beat this horse till it's dead a little bit, but it's pretty mysterious, right? There are physics considerations which might move you to say, I can't explain it in these ordinary physical world ways. This is just mysterious. It doesn't look like the world we thought we knew. It doesn't look like physical reality. You can't change the past. You can't, the world doesn't change when you look. Not things that are real don't. But this is quantum, this is down to the quantum level. These are the basic building blocks of everything we do see that we think doesn't change when we look. But it all somehow seems to be built upon changes that do depend upon observers. What the heck? That makes no sense. But along comes these guys who can simulate it and make perfect sense. And so they say, because we can simulate it, maybe this is being simulated. Because we know how to do that. Now, if only we could give an account of how that simulation comes to be, let's take a look at that possibility. There, we've just motivated this better than I ever have to myself, actually. If this isn't good enough, I just can't put it well enough yet. This is how you motivate, it seems to me, alt realism from quantum mechanics. And there are people who are driven in that direction. What do you think?
Absolutely fascinating. I was not familiar with that experiment. And so, I mean, it seems like they've made quite a few attempts to eliminate any other possibilities, but I mean, I would just always assume like something physical was getting messed up rather than just
Me too.
The particles were deciding not to do that when they're observed. I don't even know what the
right. How would
explanation would be, but yeah, super fascinating.
Not your first time looking at this. Maybe the I don't know if you'd seen the quantum eraser before, JP, but not the first time you've seen double slit.
I hadn't seen the quantum eraser before. I think that's pretty. That's an amazing experiment.
Freaking clever. If the logic pans out, we kind of skipped over the logic. I waved my hands at the logic, logic and the optics, but it's not that complicated, actually.
Yeah, no, I've heard people talk about the quantum eraser some, just as one of those. Like I think Sean Carroll has talked about it, on his podcast some. But the double slit experiment was just always so mystifying. I mean, it's so, it is incredible, and I think it's pretty easy. It's a pretty amazingly easy to understand what's going on, and yet it's like it's so. That's why I think it's such a cool experiment, because you can get a sense for why this is so weird and confusing with this pretty simple experiment. I just think that's really cool.
Too. It's like the photoelectric effect experiment, right? I don't know if you remember that, but you dial up, you basically, how does that go? You put a photomultiplier behind a piece of metal and you throw light at that piece of metal. And you might think that the harder you throw it or the more you throw at it, right? Somehow you might be able to break an electron off, and you can break electrons off. Believe it or not, just a photon coming in will knock an electron out of a certain, and you might know enough chemistry to know where you grab that material from, right? Where that ionization energy is small, way off on the left side, right, of the periodic table.
Right.
You drop something in there like that, right? And you knock it with light and you'll knock those babies off and still send down the photoelectric effect. You know, you basically put this large electronic sucking sound, a sucking force. That, of course, is not what's happening, but you put a voltage across it, a voltage difference, right? And it accelerates through that, through that photo. I don't know if you've ever seen the way that why am I drawing a blank on the photomultiplier, the piece of equipment that's basic in detection. That photomultiplier works that way. And so the photoelectric effect is when you dial up the right color, they start flying off of there. And it's not about anything but what color they are. And there's a color threshold, which is an energy threshold, right? E equals h mu. And that wavelength threshold, which we see as color, I should say frequency threshold, one over, right, is the magic. That's the magic that does it. And you just have to look. It turns out, when you look, it turns out nature behaves that way. And you're kidding me. Why would that be, right? There's something quantum going on here. That's another one of these basic experiments. I'm not saying it's the same or it has the same level of mystification going on, but it's got a similar level of marvel, because you get to peel something back and look into the quantum world, and all of a sudden it just doesn't behave the way you thought it would. And in a very, very simple way.
Yeah. I'm interested to read more about this. What was it? Thomas Campbell?
Yeah.
I'm definitely going to call him Joseph Campbell at some point, so I apologize in advance.
I know.
But,
different dude.
I think I'm interested to see how he brings it in, that, why he sees the connection with the meditation practice. And I've always heard the word psychonaut in reference to people who use psychedelics.
Yes.
Like DMT trips and LSD to some extent.
That's where I hear it too, John. But I always thought it was the exploration of the exploration of consciousness in alternative means. And I thought I lumped meditation in there, as I think they sometimes do also.
Yeah. No, I think it's a fair lumping, but I think that's my impression when someone talks about psychonauts.
So I threw that word up thinking about it for 5 minutes. So maybe I should retract it. Let's take a peek.
No, I think it works, but the connection between that, I don't know. That's an interesting jump to go from meditation or some sort of exploring consciousness to connecting that to experiments like this, or connecting it to physics in some concrete way. I'd be very interested to see how he does that.
Here's a bumper sticker version of it, and it's going to be way wrong. Okay. But it's, I think it might be the right bumper sticker, something like that. So it will have a tiny little shallow ring of truth. It's as if you live your life as a scientist, and you also meditate. And when you meditate with other people, you run into things that you see in common. And you know that when you come back from your meditative experience and you exchange notes. And there are basic principles about how things work in the world that you just experienced in these heightened state of meditations. And you get better by some measures that you can both agree upon, whatever that is, right? As you journey toward higher meditative states, and you seem to discover things down that road. You think they're discoveries because you think it and that other guy thinks it, and you weren't in the same head, but you begin you begin to think that you're in the same reality, right? And that this is somehow a journey into that reality. And I think that bumper sticker I've heard described for a variety of say Eastern meditative traditions. So that's most of what I know about Tom Campbell's efforts here. That he had sort of, I don't want to call him a guru, but I think he might have called himself one. I simply don't know enough about it whether he did. The person who he learned to meditate with, and those folks in that crowd came up with useful tools to resolve the problems which Tom Campbell saw as he was a practicing scientist, but what I mean was he learned to think like a scientist. He was trained. He was doing research in nuclear physics, as I recall. So, you know, he was an advanced grad student. And those people generally have learned to think as scientists in some measure, right? And so that's where he got. So yeah, it will be interesting to see. In particular, he's got, you can jump into his stuff for about 6 hours of video. He's got, and I've actually explored it enough to know which videos to look for. He's done a series at Calgary, and also a series in Los Angeles. And it's a series in Calgary, if I remember correctly, in which he says, this is where I really dive into the everything. I start at the beginning and I work my way up about this MBT approach. And you can, and he'll take you in rather a lot of detail. Frankly, it's amazing to me that everybody stays with him, because my guess is most of his audiences are not. If they're computer scientists, they want him to go faster. If they're physicists, they want him to go faster. And if they're neither, I'm not sure how much they're going to get out of it. He goes into enough detail very, very slowly, trying to bring people on board. And probably the way I just did it, slowly with what we just went through. Kind of like, only he knows more about it. Okay. Anyway, it's interesting that he's also a quantum. He is sprung also from the quantum world. I mean, he's looking to resolve the mysteries in the quantum world with a conscious realist, something like an alt realism with conscious agents at the root of it. And as a matter of fact, he goes on to say a lot of things about conscious agents, which at the bumper sticker level are the same sort of things that I would like to say about conscious agents. And maybe only because I'm less careful than Donald Hoffman is. He's very careful and only wants to say things that he thinks he can mathematize precisely. And I don't have that tool set. And I don't know whether Campbell does. I don't know that he does. But anyway, yeah, we'll have to figure out we'll start with a video or two just so we have an idea. All I wanted to do at this level is to say there are people who are traveling these roads. And now I think you can see why somebody might want to travel that road based on one peek at this quantum eraser deal. But you don't even have to go to the quantum eraser. That's just wonderfully, brilliantly cool, right? But it was already weird in the delayed choice. The very idea of a delayed choice already makes it unbelievably weird. And that's been in place. I don't know when that was first done carefully. But I think my guess is that's a quarter century ago or more that was done.
Yeah. Well, I think those two things don't connect as obviously to me with the psychonautics element of it. I mean, I feel like the observer dependence is really the connection with the psychonautic element, probably, right? Less the time independence, or seeing time frame change. But it's really hard to get over this whole. I don't know. I have a really strong intuition to not make claims about reality based. Not make claims about like what is based on some sort of subjective experience or something like that, you know?
Oh, I hear you. Me too.
But it certainly seems like in this experiment that the way in which a subject experiences it actually affects what objectively happens, to use those words in a really rough way.
Yeah.
And so this guy is trying to get the subjective and objective things to make more sense together.
That's true. Yeah, I also have some sympathy with them. You know, I'm wagging my head with half of me when you said what you said. I can step right into that. The problem is I can think of some clear counterexamples to it. And that is, I'm quite sure I know something about what love is. And
Yeah.
and I don't know how to quantify it yet. And it's because I don't know how to quantify it. I'm not waiting around to figure out if it's real.
Mm.
I would say it's a fundamental. It's a fundamental. It's an elementary experience of human consciousness, and
Mm.
I think parents love their children. That you come out of the womb and you never don't experience that. There are people who don't experience it, although they get something that looks like love, or they'd be dead. Right?
Mm.
It might, but it may be a counterfeit of love. It turns out to be. They might say, for example, you cared for me when I was little, meaning you fed me or I'd be dead, right? But it was just an investment you were making. You were looking to sell me someday. That's not a laughing matter, but you could imagine such a person. And in some sense, you were caring for me. And in another sense, you don't care about me. But how long does it take before someone learns that that's a real question? And this person does care about me, or deeply seems to, and I utterly trust them, right? And this person seems not to, or did seem to, and put on a counterfeit show for a long time, but actually doesn't. And that's
Mm.
a real, that's a mark of wisdom, right? And if you're fortunate, you know how to make those discernments. And you don't need to be that fortunate. I mean, this runs pretty, you're deeply fortunate if you know it. So I shouldn't say that. You're unbelievably, wonderfully fortunate if someone's ever loved you, right? Someone's just flat on your side. End of story. Right? That is, I'd say, a widespread human experience. So what I mean when I say you're not all that fortunate is that you're not picked out as a rare individual. If someone loved you, right? There are a lot of people loved you, although it is still remarkable that they do, and it's wonderful, and you wouldn't trade it for anything, right? And doesn't that seem, to me, that seems pretty fundamental. It seems like the kind of things people learn, not necessarily through meditation, but through interaction, through social interaction, and really listening to one another and really exchanging. There's a lot of exchange in knowing whether a person loves you or not. Right? There's a lot of exchange.
Mm-hmm.
So I suppose that is like, maybe that is psychonautics. If you know what I mean. There's no mushrooms involved, and there's no, there may be not real meditation involved, but there probably is some thought involved. That seems true, right? I mean, it's at some point, somebody notices that, yeah, you know what? Actually, they really do love me. They're on my side. I do think there's some metacognitive, metacognitive, and you could call that meditation, I suppose. I don't know what it is, but you got to do it. You have to notice. So anyhow, yeah, the question is, if you start with conscious realism, if you start up here, what is it you're letting in? Are you more sure that you trust the evidence of your senses than that you trust that your parents are not actually conspiring against you to do you harm? That is, it seems to me I'm fully aware of both of those things, or was. My parents are both passed, but I was really fully aware that, I mean, I did trust my senses. I don't mean naively, or maybe I did trust them naively, but in retrospect, I don't trust them naively, but I trust them some, right? I put my foot out all the time and test whether something is safe to stand on it or not. And if it supports my weight in an initial way, then I know that I can probably put that much weight on it again and it won't fail, right?
Mhm.
You must do that about 1,000 times a day, right? In the woods, just when you walk, right? When you navigate, or you trust a tree that's leaning not to fall on you because it stood for 50 years. It's not going to fall out of nowhere on you. You're going to have to cut it down. And that level of trust, that's sensory trust. And I think we have a different kind of trust that gets at that, whose object is love. And I think that is also real. And I think that might be primary data.
Yeah.
So, anyway.
I'm not sure what I think about that, but
good. Push back
Yeah,
as hard as you can. Do me a favor and push back as hard as you can, because
sure.
it would be really helpful. Because
Yeah.
I'm inclined to build on it. I'm inclined to say this is actually how you begin to build, and you build in a circular sort of way where you work around a lot of things. And we talked about keep spiraling back to things from other perspectives, and start to see connections between all kinds of pieces. But I think among the pieces you need to connect are those experiences of actually loving and actually being loved. I think those are really fundamental pieces. And if you don't have them in there, I think you can't build the whole you need to build. Which is to say there's a kind of wisdom and a kind of truth. I think those are stabilizing experiences. I think as you continue to relate to people, you don't build a worldview in which you used to deeply love people, but now you don't, right? Because that was just not the right way to look at it. I don't think so. I don't think that is not, you don't get out of that low potential energy well, to go back to that metaphor we talked about a long time ago. Right?
Yeah.
I think you fall into that and you stay in it. Raise up a child in the way she should go. When she's old, she won't depart from it. Love her, right? Love her, and she will not forget. Absolutely not forget, right? And she will spread it as if it's a really better thing when it's around than when it's not, right? Or when people live in it than when they don't. It's really better. And she may be distracted all over the place when she grows old, but to the extent that she has been raised with really regular, habitual, loving exchange. Put that in a person's life, and they're not going to turn somewhere else. Or if they do, they'll be drawn the whole time, right? There may be some large pull that takes them in a certain direction. And that, in effect, is starting to tug them out. It's a high energy pull out of the potential energy well, right? And that's a possibility. You might pull them for a while, but there's a deep pull back into this space, right? And it doesn't take a lot to untangle them, right? And get them, in effect, to come back, right, to where they were, which is pay attention to human beings, right? Stop. It doesn't matter so much what you thought you were pursuing at the expense of other human beings. You've had your priorities wrong, and somehow you know it. And I think that turn can be affected in human beings, and that's a fundamental property of human existence. And this may be kind of psychotic to make claims like that. It does start to sound like a Tom Campbell theory of everything. And so how much it's like that, I don't know. Okay.
It's fine. This conversation reminds me a little bit of Interstellar.
It does.
How the love changes the past and transcends time and all that.
Do you remember who the physicist was? They had a top flight physicist who advised that. And it might have been Nima Arkani Harai. Or if it wasn't, it was someone like him. If I remember correctly, the physics advisor was, one of those people who got to think for a living.
Yeah, I don't remember who exactly it was. But,
so good at it. Yeah, we should look that up sometime.
Yeah.
All right. Well, we've been at this for 90 minutes and we should try and quit after 90 minutes sometime. And now is a really nice chance to do it.
All right.
Sure.
Open topic. And if you want to settle that topic now, or I'll tell you what, let's not in principle settle it now. Let's settle it tomorrow. Just send something around if you want us to read something, if it would be helpful for us to read something. For whatever it is you want to talk about, give us a little bit of a heads up. And no need to read something. If the topic is such that it would be helpful to have read a few things, let us know.
Cool. Sounds good.
Sure.
Thanks, guys. Pleasure
Great.
as always.
Thank you.
All right.
Yeah.
See you.
Good to talk to you guys
Have a
again.
good one.